calculator is too slow, right? My estimation is what is it? 2.2? 2? Oh, yes. So this room sounds like we are in big Catholic church, but that's wrong, right? So something wrong over here, more absorption, eh? So increase it twice. That makes sense. Okay, when you go to the first floor big lecture hall, what do you feel? When you listen the lecture, you feel a little bit dizzy, right? Big lecture hall. Huh? You have an opposite side, there is a small lecture hall, right? And that lecture hall sounds more alive, right? Everybody agree? Right? That lecture hall I designed. I simply did not use expensive sound observing material when I designed that room. Yeah? Big lecture hall, they used a lot of sound observing material, right? Right? That's stupid. You spend a lot of money and you have lower quality lecture hall. Right? When you go to our big auditorium, what you estimate the reverberation period of big lecture hall? Not 2, right? Cannot be 2. What would be? It's about 1.2. 1.3, depending on frequency. So that's pretty bad. Okay. When you go to the, for example, famous Daejeon City Hall, the 예술의 전당, huh? How many? Have you ever been in 예술의 전당 to listen music? Raise your hand. Okay. 동수, okay. 포항, okay. How you evaluate that hall, music hall? It's not alive. Yeah, you feel that when you listen like a big, the chamber music, you didn't feel the sound is quite alive, right? It's sort of, you feel sort of dead sound. Like, for example, Vivaldi, when you see the Vivaldi, the sound has to be bright and alive, right? But when you see that kind of music in, for example, our hall or the yesterday in Jeondang, sounds that's not really bright. Brightness comes, brightness feeling normally generated by the room that has more, that has appropriate reverberation period. So I can conclude that Sabin claims that reverberation period represent the quality of room. Isn't it fantastic? It's like finding a measure that can estimate the quality of steak, for example. Quality of a steak proportional to the size. Quality of a steak is proportional to how much how much salt it has, for example, you would not agree, right? Because the quality of steak depends on many factors that cannot be controlled scientifically. If it can be controlled scientifically, what would happen? There will be people who lost the jobs a lot, right? So that's not good. Even you can make a certain oven that can control those scientific factors, right? But still, we are using reverberation period as a primary measure the sound quality of room. So that is fantastic. Yes?
We use this if the room is acoustically large. So how can we divide it? Like which one is small, which one is large?
That's a good question. That's why we have to move on to the acoustics or sound in a small space. Brilliant student. Okay, sound in a small space. Sound in a small space. Acoustically small space. What does it mean? Okay, let's start with the extreme case. Let's start with extreme case. Suppose I have a and I have a little branch over here. Okay? Or, if you like, you have a clarinet like this. And you closed every hole. And you blow and make a sound over here. And what happened? If the diameter is d and the wavelength is lambda, if diameter is much smaller than wavelength lambda, then the sound wave propagating mainly in this direction. Yeah? So that means this side, cross-sectional direction, is acoustically small, but this direction we can, or dimension, we can say acoustically large. So, duct acoustics case is the case when we have a small, acoustically small cross-sectional dimension, but acoustically large dimension otherwise. Okay?